Okay, so we're looking at question 21 from chapter 14. Probably ought to write that down. Okay, 21, chapter 14, and it says a 1.5 kilogram mass on a spring has a displacement as a function of time given by this equation here, 7.4 multiplied by the cosine of 4.16 radians a second times t minus 2.42. Okay, so for A, it wants to find the time for one complete vibration, so that's just going to be the period. So that's going to be 2 pi over the angular frequency, which is 4.16, and so that gives us 1.51 seconds. B is the force constant of the spring, and so that's going to be given by mass times the angular frequency squared, so 1.5 multiplied by 4.16 squared is 26 Newton meters. C is the max speed, so that's going to be the acceleration times the angular frequency, so 7.4 times 10 to the negative 2 multiplied by 4.16, which equals 0.308 meters a second. The max force on the mass is going to be the mass times the angular frequency times the acceleration, the mass times the acceleration times the angular frequency squared, and that's going to be 1.5 multiplied by 7.4 times 10 to the negative 2 multiplied by 4.16 squared, and that is 1.92 newtons. And then the speed acceleration of the mass at t equals 0, and so we're going to be using this equation from up here, and so that's going to look like it's going to be x equals 7.4 times 10 to the negative second multiplied by the cosine of 1.74 times x multiplied, or 1.74 times 57.3, which is 0.216 meters a second squared. And then our force of the mass at that time of 0 is just going to be equal to mass times acceleration, so that's 1.5 multiplied by 0.216, and that's going to be 0.324 newtons. I think you can see all that, right? On the very bottom, that bottom row. Cool.